Welcome back to another video. Today we are going to talk about applications of linear equations. And so basically it's just word problems that involve a linear equation. So we've talked about linear equations. You know, you have to have an equal sign, you have a variable where the highest exponent of the variable is 1. And you can solve a linear equation by just getting the variable on the side by itself. So applications of linear equations will involve you actually having to set up those linear equations. So there is a process for solving these equations, and so I'm going to go through and show you all of the steps, or walk through the steps with you, and then we'll go through and work some problems. So step one is you want to read the problem. You want to read the problem, get an understanding of what the problem is saying. Okay, you want to see what it's asking for, and you want to see what information it's given. Step two, you want to assign a variable to the unknown. So whatever it is you're looking for, you want to let that represent some letter. That's what a variable is. It's a letter that represents some value. Okay, once you assign a variable, then you want to write an equation. So you want to write an equation based off the information that's given. Once you set up the equation, step four, you want to solve the equation. So you solve that equation by getting the variable on the side by itself. After you solve the equation, you want to state the answer clearly and make sure that it's stated correctly in the context of what it's asking for. And then step six, you want to check to make sure your answer is reasonable and to make sure that it actually makes sense. So these are the 6 steps that you want to go through when solving these applications of linear equations. And so let's look at some examples and work through those step by step. Okay, for this first example, it says the product of 4 and a number decreased by 7 is 100. What is that number? Okay, the product of 4 and a number decreased by 7 is 100. What is that number? So we read the problem, and so now we want to assign a variable. So the variable that I'm going to use, this is a commonly used variable, but you can use whatever variable you want. I'm going to use x. X is going to represent the number that I'm looking for. X represents the number that I'm looking for. So that's step 2. We assigned a variable. So now step 3, we want to write an equation based on the information that's given. So first of all, product. The word product means multiply. So you got to know these keywords. You probably learned these when you were in elementary. All the keywords and what they stand for. So product means multiply. Of means multiply. Also, if you see more than, you're usually adding, or difference, subtraction. So you want to look for those keywords as well. So product means multiply. So the product of 4 and, so we have 4 and a number. So 4 times, so the and lets me know what I'm multiplying. I'm multiplying 4 and I'm multiplying a number decreased by 7. So the number is x, that's what we're looking for. But this number is decreased by 7. Decrease means to subtract, okay? So I'm not just multiplying 4 and the number, I'm multiplying 4 and a number decreased by 7. So x represents the number, decreased by means subtract, and it's decreased by 7. And it says, the product of 4 and a number decreased by 7 is represents equal. So equals 100. So this is the equation that we get, and this is step 3, actually writing that equation out, okay? Now, step 4 is we want to solve that equation. So now we want to go through and we want to solve this. So you can do 2 things here. You can actually distribute the 4 if you want, or you could just get rid of the 4 because we're trying to get x by itself. This says 4 times x minus 7. So to get rid of multiplication, you would divide both sides by 4. And so the 4's would cancel, and you would get x minus 7 equal to 100 divided by 4, which is 25. Now you would get x by itself by getting rid of the minus 7. So add 7 to both sides, and you would get x is equal to 32. So that was step 4. We solved the equation. Now we want to state the answer clearly. So we will say that number is 32. I mean, that's all you will say. The number is 32. And let's check it. It says the product of 4 and a number decreased by 7. So 32 decreased by 7. So 32 minus 7 is 25. So the product of 4 and 25 is 100. So it actually checks out, and that's how you will work that problem. Let's look at another one. For example 2, it says if 6 is subtracted from 5 times a number, the result is 9 more than twice the number, okay? So if 6 is subtracted from 5 times a number, the result is 9 more than twice the number, okay? So now we've read the problem. We're looking for a number. And so again, we're going to let X represent the number that we're looking for. So X represents the number that we're looking for. So now we need to write an equation based on the information that's given. So it says 6 is subtracted from 5 times a number. So if you're subtracting from something, it should come after whatever it is you're subtracting. So if you said 9 subtracted from 12, then that would be 12 minus 9. So we have 6 being subtracted from 5 times a number. So 5 times the number would be 5x. Because our number is x, so 5 times that number would be 5x. And we're subtracting 6 from that, so it will be minus 6. So if 6 is subtracted from 5 times a number, the result is, so is represents equal, the result is 9 more than twice the number. So 9 more than means plus, and twice the number would be 2 times that number, so it'll be 2x. So our equation actually looks like this. 5x minus 6 equal 9 plus 2x. So we have our equation, which is step 3. Now what we want to do is we want to solve that equation, okay? So we'll solve this by getting x on the side by itself. So I'm going to move this 2x over here with this 5x by subtracting 2x from both sides. So when I subtract 2x over here, I get 3x minus 6. The 2x's go away here, and I'm just left with 9. Now I'm going to get rid of this minus 6 by adding 6 to both sides. And that gives me 3x is equal to 15. Then divide both sides by 3. X is equal to 5. So we've solved the equation. Now we'll state the answer. And the answer is just the number is 5. Because we were looking for a number. So the number is 5, and so we'll go and we'll check that. So let's see if that works. So if 6 is subtracted from 5 times a number, so 5 times 5 is 25. 25 minus 6 is 19. Okay, so that's what we get. If 6 is subtracted from 5 times a number, 5 times 5 is 25. 25 minus 6 is 19, which is basically what this left side of the equation says. So we get 19. Well, it says that it's the same as 9 more than twice the number. So twice 5 is 10. And 9 more than that is 19. So you get 19 both ways. So it works out. It checks out. And so that's how you would solve that problem. Let's do another one. Okay, for example 3, it says 2 pages that face each other in a book have 269 as the sum of their pages. What are the page numbers? Okay, so we got 2 pages. So I'm just going to draw a picture. We've read the problem. So here's my book. We have 2 pages that face each other. So when I fold them up, they'll face each other. The sum of their pages is 269, and we want to know what is the number. So X, we want to assign a variable. So I'm going to let X represent the first page number. Because there are 2 different numbers, I have to pick one of those. So you can let it represent the second page number or the first page number. I just picked the first page number. I'm going to let X represent the first page number, which should be X. So just think, if the first page is page 9, then this second page will be what? It will be page 10, the number that comes right after it, because they are what we call consecutive numbers. Consecutive means right after each other. So if I say consecutive numbers, I'm talking about like 9 and 10, 10 and 11, 1 and 2. Those are consecutive numbers. So that means the number that's after X will be 1 more than X. So I would represent this second page as X plus 1. So the first page, if I let it represent X, the second one is X plus 1. So I've assigned variables to my unknown. Well, actually 1 variable, and then I've just represented both of those numbers using that 1 variable. Now, I want to write an equation based on the information that's given. It said that the sum of those pages is 269. Sum means to add. That means when I take this page number and I add it with this page number, I'm going to get 269. So it'll be X plus 1 is 269. So the sum of those pages, so that's page 1, That's page 2. When I add those together, it's 269. So now we want to solve the equation. So we're going to solve the equation first by just combining the like terms. We have an x here and an x here. So when we combine those, that becomes a 2x. And I can drop the parentheses because it's a plus in between them, which means I don't have to distribute anything. So you could just drop those parentheses. So I get 2x plus 1 equal 269. I need to solve for x by getting x on the side by itself. So I'm going to get rid of this plus 1 by subtracting 1 from both sides. And I get 2x is equal to 268. Then I'm going to divide both sides by 2. And I get x is equal to 134. So 134 is my answer. So now I need to state the answer clearly. So it asks me, what are the page numbers? Meaning, what is the page number, the first page number and the second page number? So you would say the page numbers are 134 and 135. Because if this is page 134, the one that comes directly after it is 135. So that is the answer, and then you would check your answer. The problem said the sum of the two page numbers is 269. Well, when I add 134 and 135, do I get 269? 9, 6, and 2. Yep, I get 269, so it checks out. So I know that those answers are correct. So this is how you will work that example. So let's try one more example. Okay, for example 4, we want to find the measure of an angle whose complement is 5 times its measure. Okay, we want to find the measure of an angle whose complement is 5 times its measure. So two things we need to know. Well, one thing we need to know here is, so we read the problem. Well, we ought to understand what complement means. So complement means you have two angles who add up to 90 degrees. So that's what it means to be complementary angles. Supplementary, which is another term you'll see, means that the sum of the two angles is 180 degrees. So complement, you have two angles who add up to 90 degrees. Supplement, you have two angles that add to 180 degrees. So we want to find the measure of an angle whose complement. So complement, since it adds to 90 degrees, I'm going to draw a 90 degree angle here. And so we have an angle, and I'm going to call that angle x. So x represents our angle that we're looking for. So I'm just going to call it our angle. So if this is our x, it says that its complement, meaning the angle that makes it add to 90 degrees when you add them together, is 5 times its measure. So that means this angle represents the complement because this is what I add to that angle to get 90 degrees. So it's 5 times that number. So 5x. So this is my variable, and these are my expressions to represent my angle plus the complementary angle to that. So now I need an equation. Well, what equation could I use? Well, the equation that I will use is, I know that these are complementary angles, which means when I add them together, x plus 5x, they're going to equal 90 degrees. And so now I would solve this equation. So x plus 5x, so combine your like terms and you get 6x. 6x is equal to 90 degrees. And get rid of the 6 by dividing both sides by 6. And you get x is equal to 15. And so that means our angle is 15 degrees. It only asks us for the angle, but sometimes it might ask you for both angles. So if this is 15 degrees, then this is 5 times 15 degrees, which is 75 degrees. In this case, it only asked us for the angle. So it'll be 15 degrees. But if it asks you for its angle and its complement, you will say 15 and 75 degrees. So that's how you will work that problem. So remember, complement means the two angles sum to 90 degrees. Supplement means the two angles sum to 180 degrees. So these are some examples of solving applications of linear equations. If you have any questions whatsoever, make sure you include them in the comments below. I will respond. If not, you're good to go. You want to watch the next video, which is going to be more about solving linear equations, but this time involving geometric formulas. So check out that next video. The link is in the description as well. Thanks for tuning in. If you haven't already, make sure you hit that subscribe button, and I will see you in the next video.